Hello, you are welcome to another session of the particulate nature of matter. And today we'll be looking at changes of state in terms of the kinetic theory. In other words, we're going to use the kinetic theory of matter to explain the transition of the states from one form to another. Example, from solid to liquid and even to um, gas or to gases. The kinetic theory of matter simply states that, see, matter is made up of particles. All matter, okay, is made up of particles. Now, these particles can be atoms, they can be ions, or molecules, right? Now, they have kinetic energy. Particles move, or particles have kinetic energy. And kinetic energy is proportional to the temperature. In other words, when you increase the temperature, we expect that the kinetic energy of the particles will definitely increase. Today, I want us to look at how we can explain the change of state using the kinetic theory. Now, you cannot talk about the kinetic theory without mentioning particles, without mentioning looking at temperature, and also looking at attractive forces. And so there are three key things you need to take note of if you are describing the changes in the state of matter using the kinetic theory. You need to talk about temperature, you need to talk about attractive forces, you need to talk about the particle, the kinetic, energy of the particles. And so let's look at this transition from solid to liquid and then explain using the kinetic theory how this phase or how this transition actually takes place. Now, for example, if you have a solid, for the solid to melt or to turn into a liquid, there must be an application of heat energy. And so the description of the change in the state of matter using the kinetic theory begins with an application of heat energy. That is when you are looking from solid to liquid. If you are moving backwards, obviously you are not going to add heat, but rather you're going to remove heat energy. Now, and so, by the way, the kinetic theory is also known as the particle theory. And so when you hear particle theory, kinetic theory, don't be so confused. You can, they indirectly or directly looks the same. Now, if a solid is heated, what happens is that the solid absorbs heat energy. Now, the particles in the solid absorb the heat energy. So, for example, if you put a butter, right? If you heat a butter, the butter absorbs heat energy, or any solid like ice. So what happens is that the particles in the solid first absorb the heat energy. Now, when they absorb the heat energy, you know that definitely there's going to be a conversion of the energy from the thermal energy or the heat energy to kinetic energy. And so what happens is that the particles begin to vibrate. The moment heat energy is applied, the heat energy is transferred to kinetic energy. Now, you know that solids don't move at all, but then they vibrate about their fixed positions. And so the solids will begin to vibrate. Now, listen, the vibration gets even quicker or faster when you increase the temperature. Right. Now, if you look at the next point, you see when the temperature or the heat energy, as you increase the heat energy, the temperature, there's going to be a rise in temperature. Now, when the temperature is enough, what happens is that the particles also have some maximum vibrations. They begin to vibrate at a very high levels. If the vibration is enough or sufficient to overcome the attractive forces, immediately there is going to be a transition that the solids or the particles in the solids break away from their fixed positions. And so, very, very important that we take note that when the temperature is high enough, the particles would have sufficient energy to overcome the attractive forces. Remember, the attractive forces are the forces that hold these particles so close to each other. So close to each other. Depending on the type of solid, if it's a covalent molecule, you're talking about intermolecular forces. But then we can generally use attractive forces for all these type of attractions. Right, so let's take to the attractive forces. And so first, the attractive forces need to be overcome before solids can turn into liquid. How? The molecules will need sufficient energy, sufficient kinetic energy specifically, to break or overcome the attractive forces. When that happens, the particles will break away from their fixed positions. And so there's going to be, a transition. So the particles are no longer in their fixed positions. They begin to slide over one another. And then we say that we have what? The liquid phase. So that is how the transition from solid to liquid occurs. We can also look at from the liquid to the gaseous state as well. Now, what it means is that at the liquid phase, the particles will still have to absorb more energy, because even though they break away from each other, they are close in the liquid state. They touch each other. They are close, but just that they are not in a fixed or in a lattice. They are randomly arranged. They don't have a fixed lattice as we see in the solid state, but then they are close. They touch each other. It means that there is some attractive forces here as well. And so what happens is that the liquids would have to absorb energy. They absorb heat energy. The heat energy is transferred to kinetic energy. And then when the temperature is high enough, the kinetic energy also increases. It gets to a point where the kinetic energy gets greater or become very sufficient to overcome the attractive forces that is keeping the molecules or the particles in the liquid close to each other. At this point, they break away far from each other, further from each other, and then there's a transition from the liquid into the gaseous state. So just as in the solid state, the attractive forces have to be overcome, in the liquid phase too, the attractive forces have to be overcome. So that is how you can move from solid to liquid and to gas. And you can see that there must be an increase in temperature due to what? A supply of what? Of heat energy. When we are moving backwards, what do I mean by moving backwards? It means that when you are moving from, let's say, from the gas to liquid and to solid, we can as well use the kinetic theory to explain this change of state. We can use the kinetic theory to explain this change of state. Now, it's the same principle. So from gas to liquid, what happens is that there must be a decrease in the temperature. Heat energy must be absorbed. And that is why when a gas comes into contact with a cold surface, immediately the gas forms droplets of liquid. Right? And the reason using the attractive forces is very simple. Once it comes into a cold surface, it loses heat energy. It loses heat energy. Now, when it loses heat energy, in other words, directly it's going to affect the kinetic energy. That is, the gas particles or the particles in the gaseous state will lose kinetic energy. Now, they will begin to lose kinetic energy to a point as the temperature decreases, the kinetic energy of these gas particles becomes, they get smaller, or they get, smaller, and then the attractive forces increases. And so at this point, the attractive forces gets, greater, or it becomes greater than the kinetic energy of the gas particles. And so they are forced together. They are unable to move away from each other. They are forced closer to each other, and then they begin to touch each other. And that is when there is a transition from the gaseous state into the liquid state. So remember, if you are moving from solid to liquid to gas, there must be an increase in temperature. But then the opposite, there should be a decrease in temperature. The molecules or the particles need to lose kinetic energy. And once they lose kinetic energy, it means that the attractive forces becomes greater. And so they are held to each other. They are forced closer, to each other. Now, when you further decrease the temperature, they lose more kinetic energy. And in fact, the attractive forces become even greater. And so they are forced much closer to each other. And then you have, they are forced into a fixed position. And so you have the transition from liquid to solid taking place. And that is the freezing. From gas to liquid, you're talking about condensation. Liquid to solid, you are talking about freezing. And they occur at a point. For liquid to solid, we say is what? Is the freezing point. I hope this helps. And I expect you to subscribe to my YouTube channel, share with your friends, and have a wonderful day.